Hello and welcome to Verx Gaming. My name is Professor Robert, and today I'm going to show you how to do math with binary. So, if you haven't seen my two previous videos where I've explained binary, I've explained how to transform base 10 numbers into base 2 numbers, which is binary. Click up in the top right corner. I'm going to throw an annotation. I think that's what it's called. I'm going to throw the link up there, and the link's also going to be in the description if you're on mobile. Alright, so let's get right into doing math with binary. If you guys read the title, you know what's going on. So now we're going to start with some base 10 math, and then I'm going to show you that the same math can be done with different symbols with binary. So we'll start with addition. So we'll have 7. That's a bad 7. 7, that's so much better. Plus 2 is equal to 9. Now I'm going to rewrite these numbers in binary. So I'll start with 2 because that one's really obvious. That one's a simple one. Alright, now time to do 7. Now, if you watched my previous videos, you know, so this is the 4's place. So 4 plus, this is a 2's place, plus 2. 4 plus 2 plus, this is the 1's place, 1. And this is all equal to 7. So that's how I did this. Now I'm not going to do that again in the video. You're just going to have to keep up with me, or do it. You can pause it and do it on your own sheet of paper if you want to. That's perfectly fine with me. So let's get to addition here. So this is going to be pretty simple. I'm going to write it like this for now because it's a lot easier to visualize. So we're going to drop the 1 down. We're going to add 1 and 0. Now we know that's 1. So now, remember, these symbols, this means 2. It's in the 2's place, so it's a 2. This is in the 2's place, so it's a 2. So the reason this works, I'm going to tell you the theory behind this. So 2 plus 2 is 4. Now because it's in the 2's place, there's 2 2's and 4, so we'd write it 2. However, we don't have a symbol for 2, so we're going to write 0, and we're going to carry all that 4 up to here with a 1. And now you're probably thinking, Robert, that's a 1, that's not a 4. Well, now it's in the 4's place. You see what I'm saying? So I just wanted to get that out of the way. I'm not going to say it like that anymore. I'm going to say 1 plus 1 is 2. Oh, let's throw a 1 up there. I'm not going to use the 4's or the 2's places or the 8's places when we do math in the future. I just want to get that out of the way immediately so that you people do not get confused at all, because it is painful getting confused. Anyways, so now we have 1 plus 1, that's 2. We do not have a 2. So we're going to put a 0, carry a 1 out here. 1 plus 0 is 1. And now we have the 1's place. So 1 plus nothing, nothing. Second, 2 and 4. And then this is 8. 1 plus 8, that is 9. So this symbol is congruent to 9. So there we go. So that's just plain addition. Now let's move on to subtraction. Subtraction, same concept. So we're going to subtract 13 minus, let's go 5. I like the number 5. Alright, so let's write out 13. 1 8. 1 4. 1 1. That's simple. Now 5. 1 4. No 2's. 1 1. Now what does this equal? Well, if we do the math in base 10, we know from looking at this that it's equal to 8. Now let's find, so this is going to be 8 down here, but we need to find the binary symbol for 8. So the way we're going to do that without just looking up here and converting this 8 to binary 8, we'll do it using binary subtraction, you know? I'm kind of repeating myself, but why not? Let's just drill the point in. Subtraction. 1. Oh, we should start from the right to, I always start from the left to the right, but that's dumb, because if you ever need to carry stuff, it's a pain in the neck. Alright, so this is 0. 1 minus 1 is 0. 0 minus 0 is 0. 1 minus 1 is 0. And 1 minus none, there's a 0 there. We just haven't written it. You can write it if you feel safe doing that. So there we go. Now we have what looks like 1,000. This is not 1,000. Remember, what this is congruent to 8. Because remember, we have no 1s, no 2s, no 4s, 1 8. I just realized I'm moving my mouse around. I was going to get rid of it, but now I have to keep it because I'm using it as a pointer. Okay, so there we go. So these two are congruent to each other. Alright, so we got that down. Now I'm going to do one more problem, but this time I'm not going to do a nice problem. I'm going to do one that carries. And now because we're going to start with a binary one. I'm not going to show you the base 10. See if you can guess what the base 10 is. No, don't guess. See if you can figure out what the base 10 is. We'll make this interesting. Alright, so here's our two numbers. And now the reason I chose this is because if you look at this spot here and this spot here, our 2's place and our 8's place, we're going to have to be carrying stuff because you can't take 0 minus 1. It's going to be negative, and we can't do that in this way. So let's start from right to left, and I'll explain how to do that once we get there. 1 minus 1 is 0. Now we have our 0 minus 1. And now you know this is a problem because you can't do this. Just can't do it. So what we're going to do is we're going to do our carry. 1, what we're going to take. Now we're going to go where I'm going to talk about the places here. Remember, this is a total of 4. So we're taking 4 out of here, and we're going to put 4 into here. Now remember, this is the 2's place, so we're going to have 2. 2's makes 1 4. Now this is the improper way to write it because in base 2 we don't have that symbol. Now in base 10, when you do like a problem, like let's say it's 10 minus 9, when you do base 10 you put your little 1 there, but you see this is kind of like the symbol for the 10, so that's why that's like kind of okay. But if it was with base 2, you can't just throw a 2 in there because that symbol doesn't exist in this math form. In this math language. It's kind of its own language, so we're going to write it like this. Alright, so now we have 2 of these minus 1 of them, which leaves 1 of them. It's that simple. 0 minus 0. I'm going to do the same thing over here. That was a really bad line. There we go. That's nicer. Going to carry over our 2 again. 2 of these. 1 minus 1 is 0, and then there's an extra 1 left over, so that gives us our 1. So now if you haven't converted the base numbers yet, let me give you the numbers we started with. See if you can convert them on your own. See if you can do the math on your own. Well, I already kind of did the math, but see if you can tell me what each of these numbers are. Alright, that's enough time. I'm going to tell you what these numbers are. So, 8's place, 2's place, so that is 10. Now we're going to go up here. So we know this is odd because it's 1's place, but let's do this. 1, 2, 4, 8, 16. Holy cow. 16 plus 4 is 20, so this is 21. Now this is 11, I know that because that's how math works, but I'll prove it. 8 plus 2 is 10, plus 1 is 11. And now if we do this math in base 10, 21 minus 11 is 10. So you can do it either or. It doesn't matter if you do it binary, it doesn't matter if you do it like this with base 10. Either way works. Alright, so next video I'm going to show you guys how to multiply and divide in binary. It's very simple. It should be an easy concept to grasp if you were able to get this down. Now if you weren't, do some problems on your own, check yourself, and you should be able to get it relatively quick. Alright, thank you so much for watching, and I will see you in the next video.